So we're doing L'Hopital, so derivative of top and bottom. So the top will become 1 minus cosine x over 3x squared. And then let's try to plug in again. So that will give you 1, cosine of 0 is 1, so it will give you 0 over 0 again, indeterminate. And if you haven't noticed when you did L'Hopital's homework last week, there's kind of a pattern. Sometimes they kind of repeat, and this would be one of those cases. So L'Hopital's again, limit as x goes to 0. That will give you derivative of 1 is gone. Derivative of negative cosine x is
Sine.
Yes. Derivative of cosine is negative sine, but then negative in front makes it positive. Over derivative of the bottom 6x. Let's try to plug in 0. Sine of 0, you get 0 over 0 again. So indeterminate.
Getting closer, I feel like.
Yes. Well, we know we're getting closer because plugging in 0 on the bottom is an issue. So if we do another L'Hopital's, that will just give me a 6 in the denominator. So derivative of sine is cosine over 6. Plug in 0. Cosine of 0 is 1, 6. So limits, try to plug in. Try to turn it into a polynomial and factor. Try to do conjugates if you have square roots. L'Hopital's, those are kind of your options. Okay. Questions on that one? Okay, 11. This is a good one to do. So f of x is equal to the integral from 0 to x cubed, the square root of 1 plus t to the 4th dt. I want to find f prime of 1.
Wait, so you just plug 1 into the...
No. They give me f. F is equal to an integral. I need to find f prime.
So you need to take the integral, then take the derivative of the integral? I don't understand.
Anytime we did this in chapter
5, 6.
1, I forget exactly. But anytime we take the derivative of an integral from a constant to a function, we use...
I don't remember. You plug something.
It's called the second fundamental theorem. This is one that you don't think to use, but it's not hard once you catch on to it. So you need to make sure, and when we covered this in the notes, I reiterated this. There was like 4 on the study guide, a couple on the test. If they ask you to take the derivative of an integral, which they are going to on this one, because f of x is equal to the integral, I want to find f prime, which is taking the derivative of this integral. So anytime I'm taking the derivative of an integral from a constant to a function, we use the second fundamental theorem of calculus. And all that says is you take the function, plug it in, so this will become 1 plus x to the 3rd to the 4th, times, if this is just x, the derivative of this function, so 3x squared. Now if it was just x, you'll still technically take the derivative, but it'll just be 1. So this is the second fundamental theorem. So I would start this and remember this or whatever, because this is an easy one to get if you remember second fundamental theorem of calculus. This is an easy one to get, but people never seem to realize this is what we use. So if you're taking the derivative of an integral, and the interval is from a constant to a function, second fundamental theorem says all you do is you take your function, plug it in, multiply by the derivative of that function. That will give me square root of 1 plus x to the 12th. You can put 3x squared out front. So that is your derivative. But I want to evaluate that at 1. So I would hate to see you miss a point on this one like this when the work isn't terribly hard. You just have to remember second fundamental theorem of calculus. Anytime 1 squared, so that would be 3 square root of 2, which is D. So I would, if you did not look at this and know, which it sounded like a lot of you didn't, I would kind of star or something. Anytime derivative of an integral from a 0 or from a constant to a function, you just plug in the function and then multiply it by the derivative of that function. It's a good one to know. 12. Find an equation of the tangent line to the curve x cubed minus x squared y plus 4y squared equals 8 at the point 2, 1. Tangent line problems. Those are one of the common ones. Probably top 5 common ones. We saw, and we have done this. It's been a while. We did this in chapter 2 when we did derivatives. Thing to remember about tangent line.
It's the derivative of the
What part of the tangent line is the derivative?
slope.
Yes.
Yeah.
The slope of the tangent line. I'll make a side note. Slope of tangent line is the derivative and evaluate it at whatever values they give you. So they may give you x, they may give you both x and y. You may not have to use both x and y depending on what your function is. So sometimes your function will be in terms of x and you just plug x in. So we've seen some where they give you x and y like this case and you have to plug both x and y in. Just depends. So it's this, the thing you need, the key thing is the slope of the tangent line is the derivative evaluated at whatever values they give you. Now, this is asking for the equation, so we're going to have to find the slope first, and then we can plug in x and y and m and find b, like you've done since algebra. So, I look at my equation. I notice first that this equation is not y equals. So, if I have a function that is not y equals, I'm going to have to do what type of differentiation? Implicit. So all implicit means is we are going to take the derivative, put a y prime anytime I take the derivative with respect to y, and then I'm going to try to solve for y prime. So let's take the derivative. This is 3x squared. I do not put anything. I only put y prime when I take the derivative with respect to y. The next thing is going to end up being a product rule. And I'm just going to throw the negative with the x squared and try to, instead of trying to leave it out front and distributing, just put it with the first term, the first part, negative x squared. So product rule, first, negative x squared times the derivative of the second, which is 1, but you have to put a y prime because I took the derivative with respect to y. So first times the derivative of the second, plus the second times the derivative of the first, which is negative 2x. So I did the x cubed, I did the negative x squared y using the product rule. Derivative of 4y squared, 8y prime, equals derivative of 8.
0.
Do not forget, you have to take it comes to 0.
Now I need to solve for y prime. I see we had some like this before. I see multiple y primes in there, so to get y prime alone, yep, I would keep everything that has y prime with it on the left side, either side doesn't matter, and then move everything without y prime over. So it's going to be minus 3x squared, and then plus 2xy. So I subtracted 3x squared over, and then I added 2xy. We've done this strategy before. When you have multiple y primes, get everything with y prime on one side. That will allow you to factor it out, which is nice because then I just have a single y prime. So if I factor a y prime out, I get a negative x squared plus 8y equals negative 3x squared plus 2xy. And then finally, to solve for y prime,
Divide everything by this. I just noticed all of the answers are in standard form. Good times. Okay, so there is my derivative. However, this is only the first step. So this is my slope. However, we want to know an actual number for slope. So now we're going to take the ordered pair they tell me and plug it in for x and y. That will, when I want to know slope, I need an actual number. So you're going to plug in 2 for x, 1 for y. Which will give you -6 plus 4, -2 over -4 plus 8. 4? Did I do that right? Nope.
Two's supposed. Yeah, it's an x, 3x.
Oh, shoot. There you go. So, -12 plus 4, -8. Right? Is that better? Okay. Well, that makes it end up nicer anyway. The bottom is -4 plus 8, so -2 for your slope. So really what you can do, you don't necessarily have to continue. I'm going to go ahead and continue just in case it's a short answer one on the final and you don't have multiple choice. So here's my slope, y equals -2x plus b. Now it's like algebra 1. Plug in x and y, find b. So 1 equals -2 times 2 plus b. Add the 4. So 5 equals b, right?
Yeah.
So your equation in slope-intercept form is y equals -2x plus b. And you can kind of use common sense and figure out which one it is. It is A. So you could probably technically have figured it out just knowing the slope was -2, but just in case it's short answer, I wanted to finish it for you. This is kind of I'm trying to think about common optimization related rates. This
would be kind of one of the common ones. I don't know for sure percent final, but just FYI, these are the ones I see a lot. Let's see. Let's look at. I'm gonna wait on 13 for a second.
Actually, we can do 13. Let me get my notes. Half-life. This was in chapter... I need to get out because I forget the formula real quick to use. Chapter 5? Yes. So chapter 5, we did a half-life example. Let me grab mine real quick. Chapter 5 was everyone's favorite where we did all that stuff. Let me find my chapter 5. Does anybody have their chapter 5 handy I can look at? Chapter 5. So half-life. You said it. Have seen it some in pre-calc.
Oh yeah, you're right. Yeah, you're right. Well, I just realized that
Okay. Let's see. I'm gonna wait on 13. I'll come back to that. Okay, let's look at 14. I'll come back at 13. It's pre-calc. Let me off to refresh real quick. Okay, it's a pre-calc question. It's been a while since I did half-life. Okay, 14. So 14, I'm looking similar. We've seen lots of these ones like this, at least on this final. So f of x, secant squared x minus tan squared x. I want to know f prime of pi over 4. Thing you need to remember with this one, and we've talked about it before, remember the exponents when they're right next to a trig function can go... No.
They are, it's like secant, it's being...
Yeah, if you're thinking ln. If it was ln, then yes, but remember exponents on trig functions can go on the outside. So that's what I would do first on this one. Now if I was integrating, we know the derivative of tangent is secant squared. So if I was integrating, I could go backwards nicely, but since I'm taking the derivative, I would write it like this first. And then we notice we're going to have to use trig functions. Or not trig functions. We're going to have to use what property? Chain rule, yeah. Single chain, but chain rule. So if I look at the first one, we're going to have to bring the 2 out front, keep the inside the same, reduce the exponent by 1, which will make it a first. The derivative of secant, secant x, tan x. You need to have the basic 6 memorized, like for that test.
That's dumb.
It is what it is. Derivative of the tangent x squared. You bring the 2 in front, keep the tan the same, reduce it by 1, which will make it to the first power, times the derivative of tangent, which is secant squared, I believe. Yes? Did I do anything? I think that's right.
The derivative of tangent is secant.
Secant squared, yeah. So now let's go ahead and we can simplify a little bit. This one actually works out pretty nicely. So if you simplify, this is 2 secant squared x tan x minus 2 secant squared tan x, which is 0.
What? They cancel each other.
Yeah.
Same thing. Wow.
Crazy.
Plugging that pi over 4.
Nope, because they just all cancel out. Okay.
I really never realized that. I'm intrigued to see how to do. I guess it really wouldn't matter because I'm just assuming if you
Yes.
plug it in. No, I know if you were plugging it in, it would be 0, right?
It would be yes.
Yeah.
Okay.
I'll spend the extra 20 minutes on that.
Okay.
Oh, yeah.
Okay, let's look at 15. It's related rate. Let's see what I have here. We've done something like this. A balloon is rising at a rate of 5 feet per second. A boy is cycling along a straight road at a speed of 15 feet per second. When he passes under the balloon, it is 45 feet above him. How fast is the distance between the boy and the balloon increasing 3 seconds later? So here's my balloon. Here's the balloon. Straight up. And a boy is cycling along a straight road at a speed of 15 feet per second. He passes underneath, and then he keeps going. So this bike is going to be somewhere, the boy is going to be somewhere here. So we're going to have a right triangle.
Wait.
He passes. So he starts over here, he rides, he goes underneath it, and it's 45, and then he keeps going.
So when he passes under it, though, so the height from the balloon straight down would be 45, right?
Correct, but it's yes. So I would think that would be. Let me double check it. No, because it's raising, so that 45 feet is changing. It's not a constant.
Oh, you're right.
Yeah.
Right. So that's
Yeah, the balloon is raised. The balloon is rising up.
60.
So that 45 we'll use later, but we can't count it as a constant. So let's go ahead and label. I just label x and y just because it's horizontal and vertical. Remember, key thing with the related rates. Anytime they give you a rate, which is if they don't specifically say rate, it's a speed. That is always your derivative. So I know dy over dt is
15.
5. because the balloon is rising at a rate of 5. So that's your change in the height, dy dt, and it is positive because it is increasing. Cycling at a straight road at a speed of 15 feet per second. So that is a rate, even though they don't say a rate, because it's a speed. So I know what about...
derivative of x is...
Yes, so I know dx dt is 15. Because that's... He's traveling along, so that's how he's traveling the bicycle.
Yes.
Passes the balloon is 45 feet above him. How fast is the distance between the boy and the balloon increasing at 3 seconds? So I want to know... I want to know, let's figure out what they want to know. I want to know how fast is the distance between the boy and the balloon increasing 3 seconds later. Where would be the distance between, in the picture, where would be the difference between the boy and the balloon? The hypotenuse. We'll use h. So if I want to know how fast that distance is changing, I want to know how fast.
H prime.
Yeah, dHdt, or whatever. We'll just keep doing this. So that's what I want to know. So I like setting up picture, labeling, figuring out what they're telling me, kind of so I get an idea of what I have. Next thing we're going to have to figure out is I'm going to need to figure out what formula to use.
Pythagorean theorem.
Yes, I have a right triangle, and they don't give me any information about angles. If they give me information about angles, like we've seen before, I would think SOHCAHTOA. But since the only information they give me is about the 3 sides, I'm instantly thinking Pythagorean theorem. So let's see where it gets me. X squared plus y squared equals h squared. So as I look at this, I know I want to know dHdt. That's what I'm trying to solve for. So I know I'm going to have to figure out all the other parts. I'm going to take the derivative of this. So this will be 2x dx dt plus 2y dy dt equals 2h dHdt. And you put, whenever you do related rates, you always label when you take the derivative. Now, dHdt is what I'm looking for. So I need to find x, y, h, dx dt, and dy dt. Okay, so as I start plugging in, do I know anything about x?
Yes.
Just x?
3 seconds, so it'd be 45.
Yes.
Right.
Good. So we know x. Now these are not constants. So since these are not constants, I cannot plug them in right at the beginning. I have to wait till after I take the derivative to plug them in. So x, I'm glad you guys saw that. He's traveling at 15. No. Where's that? 15 feet per second. So if I want to know how the distance after 3 seconds, x is going to be 45. Yeah, I'm glad you got it. Picked up on that. Yes. Dx dt we know is 15. We've seen one similar. Now, we didn't use the same wordage as balloon and boy, but similar setup. Now, we need to know y. Okay, I know x is 45. I know y is
60.
It's 15 times 3.
5 feet per second.
Yeah, but this isn't.
Yeah, because when it passes under, it's 45.
5 feet per second for 3
Right.
seconds plus the initial 45 feet, 60 feet.
For y?
Yeah.
Yeah.
No, it just tells you it's 45.
That's when he's
That's
directly
when he's
under it.
directly under it.
But he's pedaled 3
He's
seconds
pedaled 3
ahead.
seconds ahead.
So now
Yeah.
that balloon's risen 3 more
So
seconds
Uh,
taller.
Yes. Okay. Yes. Good point. Thank you.
Yeah.
Yeah. So 45 is when he's right here, but he's traveled 3 seconds. So you're actually going to add 5 feet per second. That's how it's raising. So now it's
60 feet.
15 feet plus the 45. Yes. So it was 45, good catch. It was 45 right here when he was underneath it. He's traveled 3 seconds, so 3 seconds later, it travels 5 feet a second, so that would be 60. So I know this is 60. So actually, you can figure out x and y from the information they give you without having to do Pythagorean theorem, like the ones we've done before. Dy dt, just kidding, you have to do it to find h, but dy dt is 5. Now h, I spoke too soon, h is not one we know, so we are going to have to do Pythagorean theorem to find h.
45, 60.
Because they don't tell me anything about how that's changing or whatever. Because that's what I'm looking for. So we have 60 squared plus 45 squared equals h squared without a calculator.
Oh god.
You can factor out a 2 from all those equations, right?
Can you do that right off the bat?
Can't you? Because it's just... And just get... Oh yeah, you're supposed to do that without a calculator, aren't we?
45.
Can you do that right off the bat? I don't know if that's going to help you any.
Yeah.
Yeah, but I mean, it just saves you from multiplying the 2 over.
Yeah, at the end, but yeah. Here, you're just going to have to do it. So 60 squared, 3,600.
Yeah.
45 squared.
2025.
Yeah, you're going to have to do good old long multiplication. 5, 5, 25.
2025.
Yeah. 22. You skip over 1. 4, 5 is 20. 4, 4, 16, 18. Right? So 5, 2, 0, 1, 20, 25. Sorry, my work looks like crap, but... Do it?
I don't know how to do that. Multiplication.
45, 45. You start with the 5. 5 times 5 is 25. Put the 2 here. 5 times 4 is 20, so it's 22. You skip over a space. 4 times 5 is 20. Put the 0. Put the 2. 4 times 4 is 16, plus the 2 is 18. And then you add down. 5, 2, 10. So carry the 1. 20, 25. Add. 5, 6, 25.
Yeah.
I think this is a perfect square. It looks nice.
It is a perfect square.
25.
Nope.
75.
Yeah, you basically have to know triples to know that. It's a...
Well, or you could.
It's a 5.
You
I
could.
don't know how you would find...
Isn't it 5? Is it a
Because
3, 4,
if you
5?
divide- If you divide 60 by 15, 45 by 15, you get 4 and 3, and then your hypotenuse would be 5.
Yeah, that's what they're wanting you to do on this one. So what they're wanting you to do is notice that it's a 3, 4, 5 right triangle. So if you think about, that's the shortcut they want you to take. I knew there had to be something. So 3 times 15 gets you 45.
Right.
4 times 15 gets you 60.
Yeah.
So 5 times 15 would be 75.
Oh, I'm making more.
Yes, I was like, this is a lot of, yeah, that's, they want you, so this is good practice. So if you're on the final and you have one like this, and you have something like this, there's probably going to be a shortcut, something like this. So if you end up with the right triangle, and you end up having to do Pythagorean, I would check a 3, 4, 5, or the numbers are going to be easy.
Why would I
I would have sat here for 20 minutes trying to
Right.
figure out what.
Well, that's why you're practicing. So if it shows up on the final, yeah.
calculate?
So here's this. Okay, so now we need to find dHdt. Levi said you could divide everything by 2 if you'd want to right off the bat. I'm just going to go ahead. 9, well, yeah. Good on multiplication again.
No calculators.
90, 15. 2 times 45 is 90. 90 times 15. 5 times 0 is 0.
Oh, no, do it the
5
other
times
way.
9 is 45. Huh?
Why wouldn't you have done 15 times 9 and then dropped a 0 down?
I don't know. You do whatever you want. I don't care. 1 times 0 is 0. 9, 0, 5, 13. 1350. 120. Oh, well, let's do 5 times 60 is 300 times 2 is 600. right? 2 times 75, 150. 1950 equals 150. Proud of us for figuring this out. I went rogue and didn't have it written down.
Yeah, you did.
150 DHDT. Divide by 150. 13? Yeah, that number makes sense. dx dt is increasing by 15, dy dt is increasing by 5, yeah, so that's a... And I would go ahead, I want to make sure you label, because I would hate to have to take off points, because IU has very strict, like, point for this, point for this, point for this. I'd hate to have to take off a half a point or something. So that would be 13, what, feet per second. Oh, you could just write out feet per second, I don't care, but... So make sure you label. Good, look at us go.
That was fun. That was
Something like it.
I guess
See, you had enough base knowledge to be able to
now
figure it
we'll
out.
take the final as a whole.
Right, if only we could do the final together. Okay, I'm going to skip 16 for now, we'll look at 17. I have a method to my madness. I'm moving around. Oh, there's 18. See, that's what I'm saying. Yeah, if we look ahead and look at 18, this is why I'm saying I think it may be beneficial to have that quiz, because this is just state the mean value.
That's 18 points if you know that.
Correct. So I'm thinking if we can do all those well, you're not going to be as, yeah.
So when it says for us to state the mean value, does it want me to like regurgitate the
That's what, yes.
formal
That's what they would expect.
That is so good.
It is what it is.
That's why we're good.
I'm not a huge fan, but I don't get a say. Okay, so let's look at 17. We did one similar to this last review. Providing the information asked for below, sketch the function f of x is x over x squared minus 1. First derivative they give you, second derivative they give you, and you do not need to check these because you were going to anyway. I don't know why. Whatever. Anyway, I would think you would just take their word for it, but we did it last time apparently. Apparently we did. Yes. So let's go ahead. These ask for just random things, so they're not asking for every specific thing. They're kind of asking for random things. So the first one is the horizontal asymptotes. So horizontal asymptote, we are going to...
So if you see that it's 1.
Yeah, so if I look at horizontal asymptote, we are looking at... The original function. Vertical asymptote would be 1. Vertical asymptote, you look at where the bottom is undefined. So vertical asymptote would be 1. Horizontal asymptote, there's a shortcut, or you have to take the limit as x approaches infinity or negative infinity. I would just choose infinity. So if you don't remember the shortcut with the degree of the top being bigger than the bottom, or the degree of the bottom being bigger than the top, whatever, the one we did last review, they were the same degree, so we took the leading coefficient. If not, if you don't remember that shortcut, you're going to have to deal with the limit. Now, this is the limit as x goes to infinity of a rational function. So I could take and divide the highest exponent on the bottom by everything. So x over x squared over x squared over x squared minus 1 over x squared. And this would be 1 over x over 1 minus 1 over x squared. And that shortcut, if you have a constant over x to any power, 0, 0, so that is 0. And I believe that the shortcut is if the degree of the bottom is bigger than the top, it is 0. So either way would do it. But so it is 0. Y equals 0. Horizontal, y equals 0. Vertical asymptote. They now ask for the vertical asymptote. We already asked that question. Vertical asymptote is x equals 1. It's where the bottom is equal to 0.
Plus or minus.
It's also negative 1.
Yeah.
Because if I square a negative, or if I square a positive here, it will get me back 0. So don't forget plus or minus 1. Y-intercept. If I y-intercept, they picked the easy one for you to find.
Yep.
Y-intercept, 0 in for x. So f of x equals 0 over negative 1. So 0. Give the intervals on which the function is increasing if they are any. So increasing, they don't ask for decreasing, only increasing. Increasing is where we're dealing with the first derivative. I have to find the critical points. So I have to look at the first derivative, figure out where the first derivative is equal to 0, and where the first derivative is undefined. So if I look at the first derivative, it's a rational function, so I'm only going to worry about the top part. So divide by negative, subtract 1. Well, what do you notice here?
You cannot take the square root of negative.
Yeah, so if I divide by negative 1, I get 0 equals 1 plus x squared. Subtract the 1. I cannot take the square root of a negative, so that tells me I do not have any critical points when I set it equal to 0. However, is there any values where the first derivative is undefined?
Negative infinity to negative 1 to 1.
Right. So my critical points are at negative 1 and 1, because that is where the first derivative, don't forget to check where the first derivative is undefined, which is at negative 1 and 1. So I still have critical points at negative 1 and 1. So to check increasing, decreasing, you take your critical points, you take your domain, which they didn't ask for the domain, but we need to find it anyway. The domain is basically all reals but split between your asymptotes, which the asymptotes are the same as critical points. So it'd be negative infinity to negative 1, negative 1 to 1, 1 to infinity. And you've seen these before. I mean, this is nothing new. It's just a review. This is why we're spending time on it. Because my hope is when you get to the final, you say, okay, I know we've seen one like this. That's my goal. So at least every question, whether or not it happens, that's my goal. Every question you look at and say, I at least know how to get started. Whether I make a little mistakes here or there, at least can, whatever. Yeah, right. So negative infinity to negative 1. Let's check negative 2, and you plug it into the first derivative. So if I plug negative 2 in, that is, I don't need an actual number, but this will be a negative over, bottom will always be positive. So negative concave down. If I plug in 0, negative over positive, so concave down. Yeah, look at your, it's, the top will always be negative no matter what, because there's no way to square something, right?
Right.
There's no way to square something that will make, x squared will always be positive. Any positive number plus 1 multiplied by the negative will be negative over positive.
So it's always decreasing.
It's always concave down. Not concave, decreasing. Sorry, wrong thing.
I wondered when you were in
Decreasing, yes. It's always decreasing, so none.
That's why they asked that question.
Yeah, tricky Ricky. I hope the guy's name who wrote this is Ricky, so I can say Tricky Ricky. Anyway. I'm tired. I was up late.
He was ugly.
I FaceTimed with my kid this morning, and you know how it shows you the picture of your face at the beginning, and you're like, God, I look awful, like my eyes or whatever.
Why are you so tired? What time did you get out of here?
9, but I was on my feet all night and running around, and I'm not made out for this anymore. I'm old. I didn't even do any activity. I just stood around and Anyway, it does, yes. Given the intervals on which the function is concave up, if there's any, so concavity, we take the second derivative, set it equal to 0, find inflection points. Here's the second derivative. So we can take the top part and set it equal to 0. So 0 equals 2x, x squared plus 3. 0 equal to both parts. I'm looking for inflection points because that will tell me how to split up my interval. So x is 0, and we notice again, subtract 3, we cannot take the square root of negative 3, so I don't get any inflection points from there. I also have to look, where is the second derivative undefined?
Isn't 0 an inflection point?
Yes.
So then you just have the interval from...
Yeah, but I want to make sure you, I want to make sure you check where the second derivative is undefined. Where's the second derivative undefined? 1 and negative 1 again.
Right.
Yeah, it's the same as the domain, but just to make sure we know it. So my interval will be negative infinity to negative 1, negative 1 to 0, 0 to 1, and 1 to infinity. So we're adding that. Since 0 is an inflection point, we have to add that in. Let's go ahead and check concavity, plug into the second derivative, negative infinity to I don't think there's going to be any nice shortcut like the other one. Negative infinity to negative 1, negative 2. So if I plug negative 2 in up here, negative times positive, so a negative over negative over negative 5 cubes, or no.
It'll be negative over positive, won't it?
Yeah.
Yes.
Negative, something squared is positive, and it'll always be bigger than 1.
It's negative over positive, yes.
Right.
So negative over positive, negative, concave down.
Oh, crap.
Ugh, I know, I just thought the same thing.
Same answer.
Negative 1 to 0. You know, let's try negative a half. So the top will be
But that's the same
It's the
thing.
same.
negative. And the bottom will be
No, it won't.
negative a half squared is positive. That will be a negative.
Right, so it'll make a
So it's a-
it'll make a negative.
Yes, yeah, just a second. So negative a half squared is a positive a fourth. Minus 1 is negative something. Cubed is negative. So it's going to be negative over negative.
So it'll be positive.
Yes. So concave up.
So this one's not.
Positive a half. You will get positive on top. And you will get negative on bottom. So that will be concave down. And then 2, you will get positive over positive. So concave up. So give the intervals in which the function is concave up. Negative 1 to 0, 1 to infinity. Sketch a graph.
How strict is their grading on graphs?
I don't know if there was one on last final. I'm not quite sure. Horizontal asymptotes at 0. This graph seems really ginormous. All right, a little bit. Negative 1 and 1. I guess you can. I have the y-intercept at 0, so I know it's going to cross possibly. That's what it's telling me. We'll look at Desmos for sure, but that's kind of what I'm thinking here. I know it's. I could find the actual points if I wanted to. So I have a critical point at negative 1 and 1. So if I plug in negative 1, well, those are asymptotes, so I'm not getting the actual point. So what you can do is just, so I know it's decreasing from negative infinity to negative 1 is decreasing and concave down. So the only way it would be decreasing and concave down with my asymptotes would be where?
Well, I mean, like
Decreasing.
Which would it be top or bottom? Bottom. It has to decrease concave down, so it's going to look like that. It could not be decreasing on the top because you're approaching the asymptotes. So I know it's on the bottom. Or if you're still unsure, plug in -2 to the original and see where your y value is. The middle part, I know it's decreasing, and then it switches concavity. So it's concave up to concave down, and it's decreasing. So concave up, smiley face, and then here it's going to switch to frowny face. So something like that. So it is decreasing, concave up until 0, and then concave down from 0 to 1. And then the last one is down and up, concave up, so down and concave up. Yep. Okay. And they didn't specifically say plot your critical points, tell what, so I wouldn't worry too much about it unless they specifically ask for it. I will fight that if I need to, if they take off points. But. Yep. Okay. That's a good place to start. We'll go back to 13 tomorrow, and then I'll give you a new one.
So for
Yeah.
on that worksheet again, real fast.
Next review worksheet is derivatives. I know the excitement is just too much.
Did you ever figure those words out that you said you
I am
figured out?
excited for that.
Probably not.
I am more excited for this. Okay.
Let me look at it and see where I'm at.
I didn't think.
I just thought of that and I was like, I don't think I ever. Which ones were they?
44, 45.